In this video, we are going to learn how to use completing the square method to find the turning point of a quadratic function. We know that differentiation can also be used to find the turning point, and completing square is only applicable for the quadratic function. We can use completing the square to find the turning point for only quadratic function. This cannot be applicable for the other functions like cubic, exponential and reciprocal function. This is only applicable for quadratic function. So let's see how to find a turning point using completing the square method. So let's take this first question. Question number 1. It is y to make a complete square. We will divide this term, which is called middle term, by 2x. Always divide by 2x. So after simplification, it will be 3. So in the next step, what we will do, we will write this x square. The first term will remain same, minus 6x. And now we will add square of this, that is 3 square, and also we will subtract this 3 square, and this 2 will remain same. Now these 3 terms will be written like this, minus 3 whole square. If it is negative, this sign will be negative. If this is positive, this sign will be positive. Now these two terms, it is 3 square, which is 9, and plus 2, and then x minus 3 whole square, it is minus 7. Now we have completed the square. From this shape we can find the turning point, and the turning point will be what? The turning you should change the sign of this number, so it will become plus 3, and take this as it is, minus 7. So this is the turning point of function this. Now let's use differentiation and check whether we get the same answer. Okay, so let's differentiate this function, that is dy over dx. It is 2x minus 6. So we know that at turning point the derivative is 0, because derivative is basically the gradient. At turning point the gradient of the tangent line is 0. So put 0 here, 2x minus 6, and x is 6 over 2, that is 3. Now we have found the first coordinate of the turning point. Now plug in this x in the given function, this function. So x square means 3 square, minus 6 into x, which is 3, and plus 2. So 9 minus 18 plus 2, so it is 11 and minus 7. So the second coordinate of the turning point is minus 7. So the full coordinate is 3 comma minus 7. Now you have observed we got the same turning point using differentiation and using the completing the square method. Now if we observe the graph of this function, you can see here this is the turning point, and you can observe the turning point is 3 comma minus 7. Now let's do this question number 5. This is the function, and we have to complete the square, and let me write like this. First I will write minus x square minus 4x and plus 6, And remember to form uh, to go for completing square, the coefficient of x should be plus 1. So let me take minus 1 common here. X square plus 4x minus 6. Now I will use the criteria of completing the square inside this bracket. So what I will do, I will divide this by 2x. So after simplification, it will give me 2. So x square plus 4x. Now I will write 2 square, I will add 2 square and then I subtract 2 square again. I will add and subtract both square of 2 and then minus 6, bracket closed. Now these three terms will become a complete square. X, because it is plus, so I will write plus here, x and 2. This x and this 2 whole square. And now these two terms, they will become 4 minus 6. Now it will become x plus 2 whole square, and this is minus 10. Now open this bracket, so minus will come with this, x plus 2 whole square, and it will make this minus and minus will plus 10. Now to find the turning point, so we always change the sign of this number. So it is minus 2 and we take this as it is plus 10. So this is the turning point, minus 2 comma 10. So yes, the answer is correct. Okay, let's see using the differentiation so let's differentiate this. It is f dash of x and the constant is 0, minus 4 and minus 2x. So this is the derivative of the function. So as we know that the first derivative is basically the gradient. So at turning point gradient is 0, so put it 0, and after solving this it will become minus 2x is equal to 4 and x is equal to 4 over minus 2, which is minus 2. So x is minus 2. Now this is the first coordinate of the turning point, and put this in the given function. So the second will be f of x. We know that we write f of x and y is the same. So let's put 6 minus 4x, x is minus 2, minus x square minus 2 square. So simplification, it is plus 8 and minus, it is plus 4. So minus 12, it is minus, let me check. Sorry, there is a mistake. So when we multiply minus 4 and minus 2, it is plus 8. So the answer is 10. Therefore, the turning point using differentiation is minus 2 comma 10, which is the same as we found using the completing the square method. And this is the graph of the function, and you can observe this is the turning point, and here you can observe the turning point is minus 2 comma 10. Same. Now the question number 8, we want to complete square first, and remember in completing square the coefficient of x square should be plus 1. Right now the coefficient of x square is plus 3. What we will do, we will take 3 common here. So it is when we take 3 common, it means we will divide every term by 3. So taking 3 common, so I will divide this first term by 3, it will be x square. Then I will divide by 3 this second term, it will be 6 divided by 3, 2x. So now I will divide this as well, it is 4 over 3. Okay, now you can observe the coefficient of x square is plus 1 now. Now we are going to use the completing square procedure. So I will divide this by 2x as usual. We divide this middle term always by 2x. So it will be positive 1. Next, I will add the square of this first and then subtract the square of the 1. And then I will write this number minus 4 over 3. These three terms will convert into complete square. So it will, because it is plus sign, so there will be plus sign here, 1 whole square. Now these terms using calculator you can found it is minus 7 over 3. Okay, now we have completed the square. Now just multiply this 3, x plus 1 whole square, and when I multiply with this 3 with this 7 over 3, 3 and this 3 will be cancelled out and 7 will be left. Now from here the turning point, as we know, we will change the sign of this always. It is minus 1 and we will take this as it is. So minus 7. So this is the turning point. And this is the answer, and this our answer is correct. Now using the differentiation, let's see whether we get the same answer. So differentiate this function f dash of x. So it is 3 to the 6x plus 6. So as we know that at turning point this derivative is 0. So 0, 6x plus 6 and 6x minus 6 and 6 over 6 is minus 1. So this is the first coordinate of the turning point. Now plug in this x in the function. So the second coordinate of turning point will be fx can be written as y. So 3x square, that is minus 1 square, plus 6 into minus 1 minus 4. So this is 3 and minus 1 square is 1, so it will be remain 3. It is minus 6 and minus 4 minus 10 and plus 3 is minus 7. So the turning point minus 1 comma minus 7, we receive the same turning point from the differentiation as we found from the completing the square. And this is the graph of the function, and from here you can observe that this is the turning point, and the coordinate is minus 1 and minus 7. Now we have done all the questions which were different, so the rest are the same. You can do you can solve them as for practice. I hope you understand how to use completing the square to find the turning point of quadratic function. And students, this method completing the square is only applicable for quadratic function. We cannot use this for other function, that is cubic, reciprocal and exponential, like these functions. We can't use this completing the square to find the turning point. Only differentiation can be used for all the functions, even for quadratic function as well. Thank you so much.